Hello everyone. So in this video, we are going to explore how to use Hanyuan video with multiple LoRa. For example, like the one I'm showing right now, it is from one of the scenes in John Wick 4. We did a video-to-video conversion and made those characters into Star Wars characters, like a Jedi shooting a laser gun, which we were able to do using different LoRa styles and text prompts. This is a video-to-video workflow that is generating these videos. And of course, we can also use dance animations like this to simulate those movements with other kinds of LoRa for the outfit and the character's appearance. There are some problems when using the default LoRa loader in ComfyUI, which is why we have another LoRa loader called the Hanyuan Video MultiLora. These custom nodes help us reduce the burlesque and other artifacts when combining different LoRa. For example, in this diagram here, as you can see, we are showing examples of different LoRa that might cause the output of the videos to have unsampling noise, like big pixel dots, as well as some artifacts that make it unable to produce those LoRa styles. By default, the LoRa loader in ComfyUI only takes care of the strength. If you are using the LoRa loader with a clip, then you will have the strength of the clip as well. And again, if you are only loading the LoRa models, it will only take care of the strength of the models. However, those artifacts and the inability to produce certain LoRa styles are not handled by the native nodes of the LoRa loader. Instead, we use these custom nodes because they have the option for double blocks. If you pay attention to your command prompts window when loading the diffusion transformer models like Hunyuan or Flux, you will see that there is a double blocks loading, and sometimes it shows an error message if you are combining multiple LoRa models in one generation. This option for double blocks helps us combine different LoRa models and styles in your output videos. For example, like the one I'm showing here, we have a character face of Emma Wilson, dance animations from my source videos, and an outfit with other styles of LoRa. We combine those three together, and we are able to make animations like this. Of course, this is not perfect for the motion or dance movements because we don't have control net or any pose conditions in Hanyuan video at this moment. Hopefully, they will have that soon. Here's another example where I used flow edit, as we mentioned in previous videos. I set the sampling steps higher and skipped the original frame steps, which you can set from the Hanyuan Video Flow Edit sampler. You do the skip steps lower in this part and the drift steps higher. This is able to make even the background look totally different from my original source videos, and of course you can use multi-LoRa in text-to-video like this. So I got a Jedi and some white soldiers in Star Wars style themes. This is using text-to-video to generate that. And of course, as I showed at the beginning of this video, we got some scenes generated using the John Wick 4 movie scenes, that iconic few-minute one-shot scene of the gunfight. I just did a very short timing of that to show a demo of how we can use different elements and LoRa styles to generate output results like this. So, like these two examples, when the characters enter the room and do some cleaning, we are able to reskin the whole video to look like a Star Wars style laser gunfight in these video scenes. So, coming back to the ComfyUI workflow here, as you can see, the Hanyuan Video LoRa loader is what we are going to use. And of course, if you have multiple LoRa models you want to load into your workflow, you will be using double or triple of these LoRa model loaders. However, I personally recommend using up to 2 LoRa models per each video generated. Using too many LoRa models is not going to make the videos have a good generation result. So I suggest using 2 as the maximum based on my experience. For example, we have LoRa for John Wick styles, and if you have something else like a character such as Emma Wilson, you can connect that as well. Just line up those model purple dot connections and pass them to your next steps, which will use the high reserve models prepared. This comes from the flow edit workflow that I talked about in previous videos, where we can use video to video with 2 text prompts for editing the video outputs. Like in this example, we are loading the John Wick 4 movie scenes and just doing a brief description here because this is the source condition. As you can see, the high edit flow guider is sending the conditions of the source videos to the guider. Then, of course, we need to do the targeting conditions, which are the editing output effects we want to generate in the video output. Here, as you can see in the editing text prompts, I am describing action movie scenes, overhead view of a futuristic space station, Star Wars themes, a male Jedi holding futuristic rifles, shooting blue lasers at white soldiers standing in the other room. The scenes include indoor CQB actions, gunfighting, and explosive action scenes. This is how we are able to generate those video styles like this. And of course, if you have other movie scenes you want to convert using video to video, it can be done with similar actions applied in the Flow Edit workflow here. As you can see, I have other time frames that were generated before and we can try those out together. So I have the scenes here and let's try some other scenes. If we can load them here, we have an overhead shot of the character walking. Let's see what we have in here. For the video-to-video flow edit using Hanyuan video, I can generate around 200 frames without problems right now because I'm using the Tcache, lowering the resolution of the videos, and also using VAE encode tiled. We have to apply the VAE encode tiled and reduce the tile size of each image frame. Then, you are able to generate a longer length of videos in your workflow. So, let's try it out. I will disable the upscaling and we'll see how that looks in the first generated video together. Okay, so we've got the generated video here. As you can see, the scenes show the character going into a room, encountering some enemies, and shooting with some fire and explosive action scenes. This follows the prompts I used. Blue lasers going into the room doing indoor CQB actions, and then some explosive action in the movie scenes. So, it's able to produce something like that based on my text prompts. However, of course, the character sometimes doesn't look clear and there's some morphing going on, but we can adjust that by using the Flow Edit sampler based on my scheduling steps. Here, you can try it out with the skip steps and drift steps as I talked about in previous videos using the Flow Edit. If you lower the skip steps, you can set the drift steps higher. If you want totally different styles compared to the source videos, then you would set the skip steps lower, like 2 or 3. And then you can adjust the drift steps to 29, 28, or even 27 in this part here. Or, if I'm using the basic scheduler where the total steps are 40, for example, and I want a completely different style in my generated video, I can set the skip steps to 3 and then input something like 37 here. This way, we'll have a higher differentiation percentage between our source video and the generated video. In this video that I just generated, since I'm using 2020, it's going to be about 50% similarity with my source video here. As you can see, the indoor decorations and everything look somewhat similar, and the character's standing position is also kind of similar in some ways. But, of course, the other 50% follows my text prompts, which reskin the character as a Jedi holding a lightsaber with a blue laser, and there are white soldiers carrying rifles here. Those 50% are doing the sampling steps to make it look different from what we have in the source video. That's how the Flow Edit and video-to-video method works when editing and modifying how the video looks using the source video. Alternatively, you can use your source video as a guide for motions. So, in this example, I'm going to run it by using the source video as guided motion. However, you'll see that the overall look of the environment will appear quite different. Even some of the motions and positions of the characters will look different as well. So, let's wait and see the upcoming result. Here we've got the generated result. As you can see, the motions aren't following the same as what we had in the source video, and because we're using very high drift steps, and if you set the total sampling steps to 40, like in my example, you need to calculate the percentage between the steps, the skip steps, and the drift steps. If you're setting it at 3, that's going to be a very low percentage out of the 40 sampling steps. So you've got to do the math here. Since the drift steps here are ticking a lot, the AI won't be able to follow the motions or even the structure of the whole scene. It won't go room by room with the overhead camera view like the original source video. Instead, we'll end up with something that looks totally different, like this. So, in order to retain the structure or the camera view from the source video, but still change things like the environment, background, or characters, I'd suggest setting the drift steps to about 60%, with the skip steps around 40% or even 30%. That will be more effective. In this case, maybe I'll turn the skip step up to 10 and make the drift steps about 30. The total counts here combined equal 40 steps, which matches our scheduler here. You have to ensure that the numbers align with the scheduler steps. If these two settings are way off, if the combined total doesn't match the scheduler steps, it won't allow the video-to-video process to work smoothly in Flow Edit. So, let's try this setting, and I haven't changed any text prompts, so you'll see the difference. Okay, we're back with the newly generated result. As you can see, when I use about 60% for the drift steps and 10 skip steps here, which totals around 30, we get a camera motion that's fairly close to the original. However, the character isn't produced well here. They're suddenly going through walls, jumping on top of other characters, and the elements here don't look too realistic. There's no sense of physics. If I want to adjust the settings to produce something closer to what I had in previous videos, like this, I'd suggest using a 50/50th split. Or if you still want the environment to look totally different, then maybe in this example, I'd set it to 25 here and adjust the skip steps to around 15. Just give a little bit more, 5 additional steps, for the skip steps to retain the original camera motions and character positions. Hopefully there's some generated result that we can take a good look at. By the way, when generating using Flow Edit in Hanyuan video, I noticed it doesn't take too long to generate. Like, you can see, it only took about 1 minute for this. Then, once I jacked up the sampling steps to 40, it took about 2 minutes, and this one took a bit longer, 2 minutes and 24 seconds. This is because I was experimenting more with the drift steps instead of the skip steps. So, as you can see, the 25 here, that's what I just set for the drift steps. Therefore, it's only rendering or spending the rendering power on the sampling steps, while keeping the remaining skip steps, the 15, aligned with the original source video. The reason I'm doing this with 40 as the total steps is that it's easier to measure things accurately. You could set the sampling steps to 10, but if you do that, there won't be enough sampling steps in the drift steps to make the video quality look better, so I prefer setting it to 40 in the scheduling steps as the total steps, or if you have the time, you could set it to 100 to generate higher quality results. You just use the total 100 steps to calculate the percentages like we did before, and that would likely produce better results. And here we have the generated result. At least this time we got something better than the last one. The character and the white soldier are more solid, and of course the rifles are there, and we've got some blue lasers going on. The camera motions are also following what we had in the overhead view from the John Wick fight scenes here. And because I added 5 extra steps compared to the previous generations, the total 25 steps here allow us to reskin the environment and adjust how it looks in this part of the video. So yeah, this is another way of making Flow Edit work using video to video. And of course, if we're working with multiple LoRAs, we can apply them here. For example, we applied the John Wick LoRA and also Emma Wilson's LoRA. So therefore, we've got some interesting things happening with the character. Although this one looks like John Wick, it's still able to simulate those action scenes like John Wick. Another example I want to show demonstrates the obvious effect of the LoRA loader. For instance, I have one LoRA for animation styles and another LoRA for character face styles here using double block text-to-video generation. This will make the LoRA styles more obvious. When you're doing Flow Edit, video to video, since it's mostly controlled by the source video, it's less likely to show you the full effect of how the LoRA models influence the output. In text-to-video, however, it's more likely to clearly show how the LoRA effects appear in the generated result. Let's try this one, and we'll see how it looks. So I've got an image, and this image is going to bring up the text using DeepSea Janus Pro. Through that, I've got the text prompts here, and then I pass the result of those text prompts through string functions into the text encoder in Hanyuan video. Right here, we've got multiple LoRAs, and I'm also applying Tcache to make the generation process faster. Okay, so we've got the generated result here. As you can see, the style is similar to my input image, and because I resized it to a smaller size, it enables faster generation if I want to do image to video as well. Of course, the anime style and the character's facial features are influenced by the LoRAs I'm using. I'm using an anime style LoRA and the Emma Wilson character face LoRA. But of course, in anime styles, you won't see the character's face as obviously detailed. However, the anime style is able to produce quick results, like this 2-second demo here. But if you want to officially run image to video in Hanyuan video, they haven't released the model weights yet. As I mentioned in previous videos, we'll have to wait for an update from their team. In the meantime, I've created other custom nodes, which I talked about in previous videos, where you can use the image as a guide to bring the VAE encoding with a similarity to the overall composition of your input image and animate that into a video. However, this won't be exactly the same as generating a video output directly from the image as the first frame. Instead, it will just produce a similar composition and use that to generate a few seconds of video, or even a 10-second video, etc. So yeah, in the meantime, I'm running upscaling during this generation process. Hanyuan Video right now are able to reduce generation times on local machines thanks to all the updates using FP8 and GGUF quantum quantization model weights, which you can use. Plus, we've applied Tcache using patch 2, which I talked about in previous videos, like in the Flux Poll ID workflow, where we also use this to speed up generation times and improve the overall efficiency of the generation processes. So, yeah, that's the overall idea I wanted to share about how to apply LoRa's using the double blocks method. Also, we're able to use Tcache or the first block cache to speed up the generation time and improve overall performance. That's how I'm currently doing it in this workflow, as well as in Flow Edit, which we saw earlier in the previous examples. The same concept applies, placing the LoRa at the front using double blocks. Remember to do that. It will help eliminate artifacts and blurriness caused by mixing different multiple LoRa models in Hanyuan Video. This is how we can do it currently, and I'll keep updating you if there are any new model weights or styles that allow us to improve video generation locally on consumer PCs using Hanyuan Video. That's it for this video. I'll see you guys in the next one. Have a nice day. See ya.